All right, so midterm review today. So no new content, just trying to answer any questions that are going to come up here. Let me go through a couple of little things about format and the schedule moving forward. So homework, there's still homework out. That homework does count toward the midterm. So homework D2 due Saturday. There will be solutions that will then be released Sunday. So you'll have that solution set before the midterm becomes available. So today, midterm review. The next lecture period is a period that I provided. So I'll be here. And so if you want to take stage one here on Tuesday next week, you can do that. You don't have to. I'm still building the exam. The exam will get finished, and so I will release it. The plan is to release it all day Monday and all day Tuesday. So anytime those days from anywhere in the world, you could start stage one. It'll be Canvas-based, uses lockdown browser. And then once you start it, it's timed. So then you get 90 minutes. So then you just have to finish it within that 90 minutes. If you start it really close to the end of the availability window Tuesday night, then it's whatever comes first, the 90 minutes or the availability window. But you've got this whole 2 days to start it, and then you get that time. If you come here, that is totally fine to do. I'll be here. Bring a laptop so you can take it. It's a Canvas-based exam, but we'll have to kick you out at 75 minutes. So I just give the extra 15 so there's any technical issues, but it's designed to be taken in less time than that. So it's designed so that most students will finish in closer to a half hour, 40 minutes, something like that, or maybe an hour for some, and then there might be a few that but by the time they hit 75 minutes, it's designed at that point it's more of a check your work sort of thing. So it's not designed to need the whole 75 minutes. And so if you do take it here, because there's a class that comes in after this, we'll have to end at the 75. You take it anywhere else, you can get the full 90. So that was the plan for stage one. So then that will get scored. You will not know your score immediately after stage one. You'll not know the solutions immediately after stage one. During stage one, you can have access to 2 double-sided formula sheets. I say they're self-produced, no photocopies or screenshots of my material or textbook material. If you want to draw a graph, that's fine. You can include that in there. So anything that you've produced, if you want to use a tablet to write it up and then print it out afterwards, that's fine as well. I just want everything there to be something that you had to go through the process of producing. So I'm sort of forcing you to study it in a particular way if you want to make use of this resource. So that's what I mean by hand produced. So it's, they can be typed as long as you typed them out. I just don't want to see screenshots of slides or things from textbooks or so on. So that's basically, I think, all of the restrictions there. You're not going to get your scores or the answers. And then Thursday and Friday, and I actually think that, so I haven't decided what I was going to do about Wednesday, but I'm leaning toward Wednesday of next week, also making that a stage one availability. Just because stage one is the timed one, I just want to give people more flexibility in when they start it. And then stage two, because it's untimed, you can come back to it all day or throughout the availability period. Then I thought maybe it's okay that that's only 2 days and stage one is 3 days. So that's where I'm leaning. I'm seeing heads nodding. Nobody is shaking their head that I can see here. So yeah, you can have a calculator. I will provide the Canvas calculator as well, the little thing at the top. But otherwise, yes, you can have a calculator. I'm not going to be, I mean, a lot of you are not going to take it in the room, so I won't be there to proctor. And so it is, I mean, I know it's true that there's, the lockdown browser is limited in what it can do. So there's a little bit of an honor system that I'm kind of hoping you're not going to load a whole, I don't think there's really a lot. Really these cheat sheets or formula sheets are meant to be a mechanism to get you to write down things and to process things that sort of way. So I don't believe that there's a lot from the class that if you were to download into a calculator screen that would really help you that much. So I'm not that worried about, what type of calculator you have or whether I can see the calculator. I do, there are all these like corner cases about are people communicating with others via calculator-like device, and they give us all of, there are horror stories about that. In the I don't know how many years I've been teaching so far. All these technologies come and go, but my grade distributions stay the same. So if people have been doing that sort of thing, I've been, they've been doing it with me forever, I guess. So I'm not too worried about that. So I don't think you'll need a calculator. You won't need to do that many calculations, but I'm also not going to get hung up on what type of calculator and whether I can see the calculator and all of that sort of stuff. So if you need it, feel free to bring it. Don't get solutions or anything. Stage 2 comes up Thursday, Friday. That will open up. And again, I will be here Thursday of next week in this room. If you'd like a space to work on it, if you like a space to work on it with others collaboratively, that's fine too, in this space. So I'll just be here just to kind of hold the room. If nobody shows up either of those days within the first 10 or 15 minutes, I may leave. But if someone's here within that first 10 or 15 minutes, then I'll just, I'll be the ride or die until you guys leave, or 75 minutes, whichever comes first. And so that's the plan. So Thursday, if you want to remember stage 2, it's collaborative exam. It's exactly the same content as stage 1, but you can collaborate with other students enrolled in the class. So if your students here in the classroom, then you can be chatting with each other. It's pretty common to have 20% of the class, maybe 25% of the class will come. The other 75 will be remote, and 20% will be sitting over here working together audibly. And then the other 5 will be kind of peppered around here, and maybe occasionally we'll float over and chat and things like that. And that's totally fine. And then I'll just be sitting up here, probably doing my own work. And so there's not a lot of proctoring there because it's collaborative. But again, I'm just here to hold the room. So that's the plan between the stage 1 and stage 2. After stage 2 closes Friday night, then I'll take a quick look at the scores, make sure everything looks good. And once they're good, then I'll post them probably that weekend, sort of the weekend going into fall break. And you'll see both scores, but the way it calculates to your total score for the for your grade is that 80% of your midterm will come from this exam and then 20% from this. So if you're doing the math, it's just 0.8 times this score plus 0.2 times this score. So that's how the grade is structured, and that's how the exams are structured. Any questions about the format, what you're allowed to bring, what you're allowed to do? Yeah. I'm sorry, what do you mean by review? Uh-huh. Oh, on the exam, I won't reference the book. Yeah. No, so I might say in materials, I might have said, hey, for this particular question, if you need help for this, then maybe go and look at this section of the book. But there are practice exams online. So I might say this in another slide. Let me see if this is next. Yeah. So in the midterm review module, up here is what I'm saying. So you'll notice there's a module that stores the lockdown browser compliance test. Go into that module, take that test, which is you basically go in, you open up lockdown browser. It's like a 1-question thing where you hit a checkbox and you hit submit. And you actually get a very small amount, fractional credit of your midterm just by doing that. And that will open up the midterm module that has all these review resources. There are old final exams, midterm exams in there that you can look at that there's several of them in there, and you can kind of see the kind of similar format. There are a bunch of resources for studying. So you can take a look at all of those, and those are inside there. And if you want to see again what an exam looks like from previous semesters, those are real exams that are loaded in there. And the exam that I build for this semester is going to be very similar in shape to those. So yeah, that's in that. So make sure that you take a look at that module if you haven't already. Of course, there's the video recordings of all the lectures that are available. And then inside all of the normal modules, if you want extra help from the book, every lecture is associated with a chapter. So, there's going to be more material in the chapters than I cover. We only worry about the stuff that I cover, it's covered in the slides or that I've identified as covered. So, but if you need a different spin on the things that I've covered, then I recommend taking a look at the Banks book for that. Okay, so those are resources that are available there. I just explained all of this. There, what types of questions I get that? I mean, they're all auto graded. There's nothing that is manually graded, and so I have a lot of flexibility in Canvas quizzes and the things I can ask for. I can ask for multiple choice questions where you have to put in multiple answers. So I can ask for numeric questions. So like some of you as you'll see in the practice exams, like you can say, well, we have this homework where I have to do this inverse transform generator, which involved a lot of math. How am I going to put that into a Canvas-based exam? Well, I can, and as you'll see on some of the practice exams, you can see how I've done that as I'll break those up into little parts, and then I'll say like, invert this PDF. And then, okay, with the resulting CDF, evaluate it at X equals 6.2. And then you say, okay, so then what number do I get out of that? And then you put in that numeric score. And then that tells me if you've been able to invert that. So on those, for some of those really long ones, like you need to, calculate a CDF, invert the CDF, and then draw a random number sample from it, then I would probably break those into 3 separate questions where I kind of start fresh on every question so it doesn't build. So you don't if you get one wrong, it doesn't lead you astray on all the other ones. So that's, one of the advantages of that is I can say, all right, now suppose you have a CDF, let's invert it. Now let's suppose you have a quantile function, let's draw some random numbers from it, those sorts of things. So that's kind of how I'll break things up. Most of the questions, I mean, generally speaking, the questions are like there's not a lot of variance in the points for the questions. So there might be a question that I try to base like if there's a question that asks you to fill in the blank 4 times, that might be worth 4 points, 1 per blank. But there's none of the questions where it's like, oh, I'm asking you to calculate a CDF here. Well, that's a lot of math, so that's going to be worth 10 points. So it's more like I kind of score things by the number of opportunities you have by degrees of freedom, really. So if even though it might take you more time to calculate the CDF, to me that's still worth 1 point. Because I've been on both sides of job interviews and things like that, and at the end of the day, you will be asked technical questions at job interviews, but rarely. I mean, sometimes you'll send people home with homework, but it's more like knowing that you need to use a chi-squared test is often more valuable than knowing exactly all the details on how to do a chi-squared test. And so oftentimes when we earlier, like in your 100 and 200 level classes, we weight things the other way, where it's like the amount of work you do seems to scale to the number of points. So it's like, oh, wow, you have to spend 10 minutes on this. Well, that must be worth 10 points. Well, only 1 minute on that, that's worth 1 point. But it's like in the real world, if you can't answer a 1 minute question correctly, that's an honest signal that maybe you don't belong there. So that's why it's kind of scaled the other way. So you might spend time doing math on here and only get a point out of it. And I hope you don't think that's unfair. If anything, I hope it's the other way around, is that you're saying so that, it's not like there's going to be no problems on the exam where it's like, oh, I didn't get my inverse transform generator right. That just knocked out half my exam because I took half the time. It won't be like that. It'll seem like, well, why is that only worth 1 point? Well, but then that can help you prioritize on the fundamentals. Because if you get the fundamental questions wrong, to me, I think that's worse than if you, forget to carry a 1. So that's the way things are scored on the exam. So there will be, partial credit, but that's only but that's in terms of based on what Canvas gives me, it might have just been easier for me to put 3 fill in the blanks in 1 question. So there'll be partial credit there, but really it's really that was 3 questions that I just put inside 1 prompt. So that's what I mean by partial credit. Hopefully that answers some of the, yeah. Yes. Oh, I don't think I said that here, but you are allowed several blank sheet of paper. Any paper in the lockdown process, you just got to show both sides. In fact, I encourage you to bring, even if you're not planning on using scrap paper, encourage you to bring it. because I encourage you after stage 1 to write down the questions that you think you want to flag. So for stage 2, you'll have a chance to go back and review. So feel free to record information about the exam on these sheets. I'm trusting you that you're not going to, like, a morning person. I see your question. I'll get to you in a second. A morning question, like if somebody takes in the morning, I hope that you wouldn't write down the exam to give it to somebody to take who's going to take it in the afternoon. That'll just, I mean, I don't plan to curve, but if there was, a sort of a curve, then like that wouldn't, like if there is like, oh, I need to make a correction because everybody got question 16 wrong and there's something was wrong there, so I'm going to give everybody a credit for question, something for that. If the morning people end up suffering because I wrote a question wrong and they give that, or wrote a question too hard, and then the afternoon people end up getting it right, then I'm not going to give you credit for that question because I'll say, look, all these afternoon people got it right, so it must be a fine question. So don't pass the answer or pass the exam to people later in the day. Just it doesn't really help anybody. But I'm encouraging you to write down those questions so to help you to prep for stage 2. So when you get to stage 2, I mean, a lot of people just remember it, like, oh yeah, this question, this question, this question, but there might be one that you forget about, or you just want extra time to look into. So I encourage you to write things down, but please don't share until you get to stage 2. Any other questions? Oh yeah, I'm sorry, go ahead. What it's so I don't. There is a mechanism now, even in lockdown, where I can have it ask you to show me that stuff afterwards, and I haven't decided if I'm going to check that box to turn it on right now. I haven't, because I don't really care about what things look afterwards. I've tried to think of all the different ways that a really mischievous student that is not most of the students in this class could somehow, but I just don't see, I don't see how it would be that helpful. So I'm not gonna, it's not gonna be like some people when they give these exams, they'll like have you show your scrap paper so they can then grade for partial credit. But like I said, I'm not grading for any partial credit is formally built into the questions. So I'm not going to be looking over each one of those. So I probably am not going to ask you to look at things after the exam, but during the before exam period, I will have you just make sure that all the sheets are blank except for the 2 sheets that I've provided or asked you to, or allowed you to provide. Does that answer your question? Okay. All right, let's see what else we got here. So I can sort of give you the general philosophy here, but I don't know exactly how many of each type of question I'm going to have there. If you look through, I mean, I've given you 4 or 5 different midterms that I've written before. You can see similarities. Some of them were paper-based, some of them were Canvas-based. So some of them you actually can take, I think practice versions that are available to take through Canvas. You don't get any points for them, but you can evaluate how well you're doing. And there's a lot of similarities here. This is roughly, I mean, I try to make most of them these kind of multiple choice type questions, elaborated. Maybe they're multiple choice in terms of drop down boxes, fill in the blank type questions. Maybe I'll put a couple fill in the blanks in one passage, just so I can kind of related fill in the blanks. But and then a few relatively easy numerical problems. Like I might, as you'll see, I like to give you the hand simulation table, and I'll just put like holes in it, and then I'll have you fill in those holes. So given that this is the interrivals, these are the service times. It's a a simple one server process. Then we've got the FEL on every every entry of the FEL on every row except for one, and then I'll ask you to fill in a number of that FEL or something like that. So those are the types of things that are these kind of numerical problems. Statistical tests of uniformity and independence of number sequences. So here's a number sequence. I might just ask you to look for patterns. So, do you, can you spot non-uniformity? Can you spot lack of independence? Or I'll specifically say use a test. And I may or may not tell you which test to use. And then a design problem or 2. So we've now talked about random number generation and random variate generation. We've talked about discrete random number or random variate generation and continuous random variate generation. It's definitely, that's one of those skills that you definitely want to have because you do run into distributions that Arena doesn't have available. And so you just, want to make sure you guys have a practice and how you build your own random variate generators. And so at least one, maybe two design problems, but that's the rough structure. And again, if you look at the sample midterms, you can see how I do this and you can see a lot of commonalities there. The big thing is like when I build these exams, I look at the kind of learning outcomes, like sort of the what you're supposed to get out of every unit, and I just sort of then say, well, if that was a learning outcome for this unit, then what's a question I can write about that? So that's this is usually how it shakes out, but it's not like I'm targeting this. But I try not to make them everything really hard fundamental concept questions. I do try to have a balance. There's this thing called Bloom's taxonomy that when we design tests, we're supposed to sample from, and so there's questions that are more definitional. There's questions that are more fundamental. And then there are these design questions. And this basically comes from Bloom's taxonomy, this distribution. So there'll be more of those definitional questions, less of these synthesis questions. So you're not going to have a bunch of design problems, just maybe one or two. So that's kind of the philosophy behind that. So the way things are structured here, and then I'm opening up this for questions, is that I've got in this first section from the first 4 homeworks, just some feedback that, from looking at those homeworks, what are sort of the common pitfalls, things to think about, what to take from those homeworks onto the exams. And then after that, I've got this greatest hits slides where I've basically gone through every set of lecture slides for all of the units up to this point, units A through E, and just picked out a slide or two from each that I think carries the key points of that lecture. But that's just here to help generate questions. But the primary reason I'm here is to help answer any questions you already have. So are there any questions content-wise, like either about the format, the structure of the exam, or about the content of what goes on the exam? Anything you want me to cover? I can work a problem, I can connect up the tablet, I can actually work something out, or I can just answer, or we can just keep moving forward, and as things come up, you can raise a hand. But anything anybody wants me to cover immediately? Okay, so as things come up, please feel free to call my attention to it. So homework B1, this is a fundamental thing. Like you definitely need to leave this class being able to do homework B1. So that's knowing the definitions of all these things. Knowing we've got events, activities. The difference between instantaneous and the idea here that this is a duration and these are instants of time. That's an important concept. State variables and states is an important concept. And the relationship between events and state variables is an important concept. Being able to, I already mentioned this, definitely be able to execute a DES by hand. So that is a key thing that now that you're using Arena, you won't have to do simulations that way, but you do often have to debug simulations. You have to know that that's what's going on behind the scenes in these simulations. How scheduling works, that you schedule activities, and so like the events bracket activities, you schedule one activity at a time. So you don't say that, well, I know that there's 3 arrivals coming, so I'm just going to schedule all 3. Well, you don't schedule those events. You say, no, I know that an inter-arrival duration has started, so I schedule its end. That's the mental model you should have. I know service has started, so I schedule its end. You schedule the end of things. You don't schedule the start of upcoming things. You schedule the end of things. But the end of things will start new things. Whenever something new is started, whenever a new activity is started, you schedule its end point. That's how the idea is there. So any questions about those fundamentals from homework B1? Terminology, hand simulation. It is reasonable I could ask questions about you can see in previous midterms, I'll do things like saying, well, what if we had two servers? If we had two servers and not one server in the checkout line, then how might the FEL change? And so does anybody have an answer for that? Like what would be a major thing as you were scanning down through the FEL? Now that you have two servers, what might you notice now in the FEL that was different than when you only had one server? Any thoughts? How would that change the event distribution, the distribution of events in the FEL? So remember, in the past, when you had one server, how many departure events could you see at a time? One, up to one. So when there's one server, there can only be one service activity going on at a time, and an event ends an activity. So if there's one server, if the server's busy, then there's a departure scheduled. If the server's not busy, there's no departure scheduled. If there are two servers, then you could have two service activities going on at the same time. And in that case, you can have two departure events scheduled, one for one server and the other for the other server. So once you have two servers, then now you can have 0, 1, or 2 departure events scheduled at the same time. So that's a type of, that's not one of those definitional questions. That's one of those kind of in the middle of blooms where it's, you have to sort of think through that. Like where does this departure limitation come from? I'm like, oh, the departure limitation comes from the number of servers. I increase the number of servers. I increase the number of possible departures that are scheduled. Okay. Homework C2, a lot of plug and chug for the random number generation. So no, you don't need to worry about middle square and stuff like that. There are hangups that we see semester by semester for this question. So remember, for the linear congruential, the LCG, the random number is this internal number divided by the modulus. Make sure that you don't use the seed for one of those random numbers. So it is very reasonable on the midterm that I could give you a seed and I could say, use a linear congruential generator, generate the next 5 numbers, and then give me the fourth number, and that will be the thing that I ask in a numeric prompt or something like that. And so, but you have to know that the first number doesn't come from the seed. The seed gets plugged into the LCG, and then that generates X1, and X1 is what generates the first number. So just know that because we provide the seed, it's like it's not random. So you don't want to just generate the random number from the seed. So that's one of the things. The other thing, just because at this point you may not have to do a lot of numbers, there's a lot of weird numerical glitches that come up here. And so common one is realizing that 0.18 is greater than 0.127. In the heat of the moment, you might flip that. So just remember your places. I mean, it seems it seems like it's silly that I'm reminding you of this, but trust me, we see on this homework in particular, on the homework where you have the time, we see this happen. Is that people say, oh, 127 is greater than 18. I'm going to quickly, make that, so when I'm doing this comparison in my tables, my statistical tables, then I, make that. So, just be careful about place value. It definitely comes up, this place value stuff. So likewise, this is another big one. If the modulus is 1,000, make sure you've got enough zeros. So if you just happen to get an X3 value of 71 and the modulus is 1,000 and you want to generate your R3 value, then remember it's not 0.71, it's 0.071. So again, it happens a lot, more than you might think. So if we've got these degrees of freedom issues, so for a KS test, the degrees of freedom is the number of samples. That's very different than a chi-squared test. So chi-squared test is the number of bins minus 1. KS test is the number of samples. So remember that. For both the chi-squared and the KS test, if I say it's a 5% significance level or a 5% type 1 error, you go to the 5% column. That's different than if it is a Z table, then that's probably a one-tailed table. So I'm usually going to ask you to do a two-tailed test. So if I ask you to do a two-tailed test and I give you a one-tailed table, you have to cut the significance level in half. because you're only looking at one tail and that gets doubled on the other tail. And we'll talk more about that after the midterm about where that comes from. But just, those are the tips here. So chi-squared and ks, you just use the alpha, but the ks, you use the total number of samples as your degree of freedom. For the chi-squared, number of bins minus 1. Any questions about any of this stuff? Okay. How interpreting these tests. So there's just in the end of this question, how it's graded. When you see that you get a critical value or you get a statistical value that's greater than the critical value, want to make sure you actually say, something more than just hypothesis is rejected. So, you want to know that when the hypothesis is rejected for a chi-squared test or a KS test of uniformity, then that means that the numbers are non-uniform. So, I'm not going to ask you on the midterm, was the hypothesis rejected? I'm going to ask you, are these numbers uniform? And so you have to know that, well, if I reject the hypothesis, what does that mean? So that's just sort of what I'm trying to, remind you here, is like knowing, how does this test relate to the properties of a good random number generator? Okay. Any questions about that? All right. And then the last homework, the homework that's due this Saturday, this, is just, these are things that I talked about in the last lecture as well, but just don't only take antiderivatives. So if I give you this PDF, this is not the right CDF. So the student here just takes the antiderivative of each row and doesn't consider the effect of previous rows on the integral. And so that ends up being incorrect. And so that's why this CDF is not a CDF. How do I know that this is not a CDF? If I look at this, this piecewise function here, what is a red flag that this can't be a CDF? Which 0? At the bottom, why is that a red flag? It should be a 1, great. So CDFs start at 0 at negative infinity, but by infinity, they should go to the limit of 1. So if it, you say, well, where does the 1 come from? It's all of the accumulated pieces from each one of these portions here. So before you get an opportunity to go to this third row, you have to take this second row and add it to this. So you can just evaluate this at the end of the row. It's like 1.5 times 0.25. That will give you a constant. You add that constant to this thing, and now you're good. And then that constant plus this evaluated at 2, that should be equal to 1, and that 1 will be there. So that's a little trick here, is that if you don't want to carry the integrals and try to do them over and over again, then generally speaking, the thing that you add to the next row is the previous row evaluated at the end of its range. Any questions about that? So I think I've got the correct, right, that's what I was just saying there, it should be 1. So if we did this the correct way and spelled it all the way out, it's this ugly triangle. So I can, we can walk through this. I'm not going to step through every point here. I'm just going to get to the end. And so this was the right one. And so we can see here that that these things, and that's the other thing here too, is that also remember in each individual row, it's not just the antiderivative, you have to consider the limits of integration. So there's the limits of integration within the row, and then there's the contribution from the previous row. You got to have both of those. And that's how you get this thing, which starts at 0 and ends at 1. All right. Any questions about that, going from PDF to CDF? So definitely you can imagine I give you a PDF, I ask you to do the CDF, and then I say something like, now evaluate the CDF at this particular value. What number do you get out? Or I might be cagier and I'd say, pick the range. Like I might say, what number do you get out of this? I might ask you that for a numeric value. Or I might say, is this value between 5 and 6, between 7 and 8, or whatever. And so gives a little bit of slop there. Okay. All right. The other, I guess, thing here is this here is a continuous probability density function. In this class, our random variables are either continuous or discrete. We don't, in the real world, you have random variables that have both combined, but in this class, we keep them separate. So if you're doing these integrals, then that should mean that this is a continuous probability density function, which should mean there won't be any abrupt jumps in your CDF. So another way to check to make sure that you did your CDF correctly is to evaluate your CDF at each one of these boundaries and make sure they agree. So if I evaluate this portion, this second row at 1.5, it should be identical to this portion at 1.5. So that's another tip. That doesn't hold in general for probability distributions that have a combination of discrete and continuous parts. But in this class, if you're doing integrals, it's all continuous. There's no discrete. And so in that case, there will be no abrupt jumps in the CDF when you're doing one of these problems. Okay. Then inverting. So choosing intervals to invert, that's an issue. Remember, the CDF maps the entire real line to the intervals 0 and 1, but you don't have to invert the entire real line. You only have to invert those rows that are non-constant, so these inner two rows. So the inverse CDF maps 0, 1 to the range of x. The range of x is only the points where the probability density function is greater than 0, which are only the rows where the CDF is non-constant, which are just these two in the middle here. So that's what we're saying there. So the range of this one is just going to be from 0.5 to 2. So this is telling me that I only need to worry about inverting this CDF for this 0.5 to 1.5, and then for this 1.5 to 2. Those two ranges, those are the only ranges I have to worry about inverting, because that's the full range of this random variable. So my inverse CDF will only generate those values because that's how the random variable is defined. So this tells me that how do I figure out my ranges of R? I'm just going to take these ranges and plug them in to these expressions. And so if I plug in 0.5 to 1.5 into this, that will give me my ranges of R. If I plug in 1.5 to 2, that will give me my ranges of R as well. Get back to just the simple guy there. All right. So I think that's what I'm doing here. So I'm not going to go through this. We just went through, but if you need another example of this, that's me figuring out that this range of X corresponds to this range of R. And then for that range, doing the inversion. So just for that row, and then I do the inversion for the other row as well. So that's what we do down here. Yep. Mm-hmm. Yeah, so the question about so you're asking about, like, could this be a less than or equal to? Specifically the 2. Oh, could this be a less or equal to there? So it's for a continuous probability density function, there is no mass. Like, remember, the probability of any slice, any single outcome is 0. So we get a lot of freedom into what we want to do with those boundaries. So if I were to give you a CDF that was written so that this was a less than and not a less than or equal to, you would do exactly the same thing. It would not change anything about the problem, because you don't actually change the probability of the outcomes, because the probability of 2 exactly is 0. So so you've got freedom to kind of play with those individual points. That's actually when we get to, in a more advanced class where you start combining continuous and discrete, that's actually kind of what you do, is you can pick off particular points and you say, well, I'm going to make that a less than, and then I'm going to put a delta right at 2. So now I say that 20% of the time 2 happens, but then the other 80% of the time is spread out continuously over all these other outcomes. So you don't really have to worry about that individual thing. Likewise, if there's and I got a question about this over email, If there's a less than here and a less than or equal to here, and you're having trouble, or if it's like maybe this is a less than and there was a less than or equal to in the part that you're not inverting. I think that was the question I got over email. And it was like, how do I deal with that? Because the flat portion seems to have an outcome. And again, it's one of these things where with the CD, well, for it if you can rewrite the CDF and it doesn't actually change it, like if you can move, if this happened to be a less than, and it was a less than or equal to in this previous piece, if you can just change that to a less than and this to a less than or equal to, and it doesn't actually change the function, like it evaluates all the values the same way, but it makes it easier for you to wrap your head around it, that's fine. You can make those other, because they're equivalent. They're just written a different way. But again, when it comes to continuous probability density functions, because there's no mass at any particular point, only density, then we don't actually care about what happens at individual points. We only care about what happens at ranges. All right, any other questions about this PDF, CDF inversion stuff? Okay, so then we got that. Here's our sanity check. So the thing that I like to do when I'm doing these things in a time crunch to make sure I did it right is you should be able, I've created the inverse CDF and I have the CDF. If I put them together, I should get the identity function. What I mean by that is if I take a value in between 0 and 1 and I plug it into the inverse CDF, it's going to give me a value in my X range. If I then plug that value back into the CDF, it should give me the value of R that I started with. Likewise, if I start in a value in my X range and I plug it into my CDF, that will give me a value between 0 and 1. If I plug that into my inverse CDF, that should give me my X range back, my X value back. If it doesn't, then that means that I've messed up. If it does, then that is an excellent sign that I've done things correctly. Okay. Questions about that? Those are what I mean by design problems, getting to that point. So just saying that there. And then the last part of that homework, the inversion part, this is, it seems, it happens enough that that's the reason why it seems like it's a weird thing that, it's like a special case, but there are a bunch of functions that are X squared like that when you invert, you have to make this decision of on which function, which part of the function, and I hope you see that although X squared is a function, when you flip it across the diagonal, then you have to make some choices. That's the reason why a square root, you have to decide plus or minus, because they're both accessible or acceptable, but only one can exist at a time in order for it to be a function. And so that's what we've got here. We're saying that if you happen to have a CDF like X plus 1 squared, this bowl, so that the CDF is restricted so that it gets rid of this side of the bowl. And that should make sense because a CDF has to start at 0 and end at 1. So it's 0 up until -1, which is the bottom of the bowl. And then it's the bowl from -1 up to 0. So, but if you just look at this internal piece here, that is a subset of a bowl. So when you invert it, you're basically saying, I need to make sure that I'm only inverting the right side of the bowl and not the left side of the bowl. And how do you know that you're inverting the correct side? After you do the inversion, you check your range. And am I generating values that are in the X range or not? So that's what I want to make sure you know how to pick that. It's not arbitrary choosing, particularly in square roots. Like up until this point, it's always been like, oh, when I take the square root of something, then I either get a plus or a minus, and I have to just accept both. Here, it actually matters what choice you make, because you have to make sure that you're inverting the CDF, which is the right side of the bowl, and not this other thing, which is not a part of the CDF. Okay, questions about that? All right, so that's all I'm saying here, is that when you do this inversion, you're going to set R equal to this. You now have some choices. It's either going to be -1 plus square root of R or -1 minus square root of R. But when we look at the range, we see that it has no values, like it has no support. That's the term we use. When it's out of the range, we say it's not supported. So there's no support less than -1. So this x, where I'm doing -1 minus a positive value, is invalid. It just doesn't make any sense. So that means that I'm going to choose the plus because that is the only thing that's consistent with the range. Questions about that or anything? Okay, I think those are the last notes I have on the homework. So at this point, again, I can just do a lightning round through all of the slides, like not all of the slides, but the highlights from each lecture that I think were the important points of that lecture. But if there's things that are really weighing on you that you want to, hear an answer to before you go into the midterm period, now's a great time to ask those. Otherwise, as you see things, feel free to ask them too, but just want to make sure I don't miss anything. Okay. All right. So, start out, what is a model? Model answers a what if question. Remember that? That's an easy one that I could put on there. Some version of what type of question does a model answer, or what's a general definition of a model. Models don't have to use computers. Models don't have to use math. Models don't have to use animals. Models, all they have to do is provide help answering a what if question. And so the models we use in this class happen to be computer-based models. They help us answer what-if questions like, what if I configured the airport this way? How might I expect performance to change? That's why that's a what-if model. But in general, there are other ways to model things. And when you have a stakeholder come to you and say, I'd like to do this operations research problem, the answer is not always going to be, let's build a sim. So there might be other ways to use a model to answer that what-if question. So that's all we're saying here. Models also, they don't have to. If I ask you a philosophical question about does a model have to include everything, or is the goal of a model to be 100% correct? It's to be insightful. It's to help provide new insights into a what if question. It's not meant to be a perfect depiction of the world. So that's the philosophical side of things. Know the definition of stochastic. If I am lazy and, I might just ask, like, is stochastic a synonym for random? And the answer to that is no. Stochastic is the use of randomness to simplify models. It is not a synonym for randomness. So don't, if you can talk about that an outcome is random, that means that it really, there is no deterministic way, but we can say, or we're modeling the outcome with a stochastic model. It means we're assuming it's random, even though it might not be. A lot of the, again, philosophical stuff from those early lectures. No definitions. We already talked about, entities, attributes, resources, state variables. Know the difference between activities. No delays, activities and delays. The idea of a conditional versus an unconditional wait. It's a really important concept. Know about inputs or activities, outputs or delays. Know how to do and by the way, and now that you're in Arena, I can point this out. There is a step in the play controls, the run controls of Arena. Next to play, there is a step function here where you can actually step through the steps of a model. And before this class, if you started to do that, you think, well, what does it mean that a step? And you might look for like, is that like a time step? Is like every second? But no, it's stepping through its event calendar. You can ask Arena to show you its event calendar, and it is steps through each one of these time points. So you can go step, 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 and it will go to the next event, whether that event is in a year or it's into milliseconds. It'll go to the next event. So, know, how to interpret this table. If I gave you a smaller table than this, it'll probably only be, 3 or 4 rows, and I leave out things like I might leave out, the customer line. I might leave out certain events. I might leave out a time at certain events. Then can you fill in that missing information? Can you answer questions about, can you spot errors? Like if I put 2 departures, if this is a 1 server queue and I put 2 departures in 1 line, can you grade that table and find the mistake? Okay. The timelines, delays, activities, which ones are inputs, which ones are outputs. And already kind of talked about that, key points. So questions about that from that first unit? Introduction? All right. So then we also had probability. So this is, our lectures, D1 and D2, input models, and then how, common distributions that we use. So this idea of what an input model is, know that term input. So that's another easy definitional question I might ask, what are the inputs of simulations? The inputs of simulations are not the entities. They might look like they're coming into the simulation, but entities are not inputs. Probability distributions are inputs. The input models, the way those probability distributions are shaped affects the output of the sim. So the output of the sim is like to you, the analyst. To the analyst, the output of the sim are the data. And the input of the sim are the distributions going into the sim. To the analyst, we don't care about entities. Entities are just water flowing through a fountain. But we do care about the distributions, how we're turning that water up and down as it goes into that fountain, and what shapes it makes when it hits the fountain. So how the water looks when it comes out of the fountain is really the output. How the water flows into the fountain is really the input, not the water itself. Same thing with the entities. So inputs and then, what distributions. And so I mentioned these are the key distributions I want you to know. So, know that if we're talking about a failure time distribution, that's continuous. So it must be one of these. And if it's a failure time distribution, it can't be negative. Well, if it can't be negative, then it's probably not a normal distribution. And most of our failure time distributions are non-negative, come from this group here, exponential, Erlang, and Weibull. If all we know about it is an average, so now we know it's a non-negative number, random variable, with a known average that could be anything. It could go to infinity. Then our best choice is the exponential. If we know something more, if I say it's the sum of two independent failures, then maybe it's, an Erlang. If it's a funny shaped one that's sort of arbitrarily shaped, then maybe it's a Weibull. So knowing the times in which we use each one of these, that's an important one. Knowing how this so-called Poisson process or Poisson counting process relates to these. And that's specifically the relationship between the exponential in the terms of waiting times between arrivals and Poisson, the other blue one here, which is discrete. Know that Poisson is discrete. It's the count of arrivals in a duration. So, and those two things combine together into the Poisson counting process. Know that in a Poisson counting process, the inter-arrival times are independent and there's no simultaneous arrivals. That's like, key features of Poisson process. Know that an exponential is memoryless. What does that mean? So these are sorts of things that, good trivia to know about the terms behind me. Any questions about these? Okay. And this is just a cheat sheet for those. So this is my summary for the continuous ones. You can see, like, generally speaking, what are features or use cases? What are the parameters? So it's useful to know how many parameters for each one of these. So know that a uniform takes 2 parameters, min and max. An exponential only takes 1. A triangular takes 3. Those are good. Know that the kind of exponential relatives, Weibull and Erlang, they take the exponential rate, but then they have a shape parameter. In the Erlang, it is the number of exponentials being summed. In the Weibull, it is just a generic shape parameter, which allows you to bend it in one way or another. Yep. It's more of a what type. After the midterm, we're going to then talk about how, if I give you a data set, how do you choose these parameters to best fit that data set? That process is something we cover after the midterm. Likewise, you don't need to know PDFs or CDFs of these distributions. If you need those, I'll give you them. I don't want you to have to memorize the PDFs and CDFs of these distributions. But knowing their general shape, knowing that a normal distribution is symmetric and hump-shaped, knowing that an exponential kind of looks like that long slope, knowing the general shapes, the kind of qualitative shapes is important. But knowing actually the format of the PDFs is not for this class. This is the discrete side, same deal. Got the parameters here and got the general use cases and properties of this thing as well. Questions about any of these? Okay. And then, rounding up here, kind of the last things here are random variant generation, random number generation. Last two things we covered, things that are, you have less time to sort of let marinate, but most recent, hopefully freshest in your mind. And so, the required features of a random number generators, PRNGs, are uniformity and independence. So if I ask you what things must be the case for a random number generator, those are the two things. We also talked about things that are desired, but these things that are desired are not the required things. And so back when I would have people write things in, then these would end up being distractors that the first time I had this class, I wasn't anticipating. I'd say, like, I thought it was a gimme. Like, what are the two features that are required of a pseudo-random number generator? And I'd get things like fast, and I'd realize, oh, well, I see where they're getting that from, and I didn't emphasize this. So this is me emphasizing it, is that the required features are uniformity and independence. You got to have those before you can even enter the market of random number generators. After that, then you can get competitive advantage. Like, you can say one random number generator is better than another for these reasons, and that's these desired features down here. You should know about the desired features, especially know that every random number generator has got a seed that allows you to reseed it, to effectively rewind the universe, so you can replay that sequence again. But it's so that makes the random number generators portable. It also means that a random number generator on my Mac will generate the same numbers with the same seed on this Windows machine as it will on a high performance computer in the Seoul cluster that they've got here at ASU. So as long as I know what type of random number generator and what seed I used, I get the same random numbers everywhere. That's what I mean by being portable. So knowing those features is definitely important. Those requirements, though, are uniformity and independence. And that's why we have tests for them. We don't have tests for these things. So if you're trying to remember those. So then those, how to generate, LCG, the only random number generator I want you to know about is to be able to calculate numbers with an LCG and to know why a CLCG exists. So I'm not going to, I could ask you, I could say, here's a formula for a CLCG, calculate the output of the CLCG. But if I did that, it'd be primarily to test you on whether you know what an LCG does. So know how to do this. Know that your first seed, that does not generate the first number. It goes into the first expression that then pops out this X1 value, and that X1 value will generate that first number. And again, place value. 2 over 100 is 0.02, not 0.2. It happens a lot. So questions about the LCG? Plug and chug, just know the formula. I won't give you this formula, so know that formula. Okay. Test for independence, know about this term autocorrelation. I missed test for uniformity, know the chi-squared and the KS test. I could ask you to do either one of those, a small example of either one of those tests. Autocorrelation, I'm not going to ask you to do an autocorrelation test. I didn't show you how to do that. Know the term autocorrelation, self-correlation, and how that ends up characterizing the amount of independence in a signal. If a signal is completely independent, which means its history doesn't predict anything about the future, then that's what we call a white noise signal. And so that, you can figure out the color of a signal by doing an autocorrelation test. We'll see more of those after the midterm. For now, I just want you to know the term autocorrelation. It's sort of self-correlation. How independent is the signal? But we will then, do a runs test. And so I showed you how to do a runs above and below the mean. That's the test you should know how to do a runs test on the midterm. You could be asked to do one of those. So examples of these things, chi-squared example, I give you 30 numbers. I tell you how many bins. You have to bin them. You have to figure out the number that fell into each bin. You have to figure out how many should have fallen into each bin if it was uniform, and then calculate this chi-squared statistic. Now, knowing this 5 here is important. Knowing that the number of expected counts in each bin needs to be 5 or more to apply the chi-squared is an important thing to know. That's the expected counts, not the actual counts. The actual counts can be less than 5. You can still apply the chi-squared, but the expected counts has to be greater than or equal to 5. Calculate the chi-squared, look it up in a table, already talked about it. Degrees of freedom, that's an easy one to mix up. If I give you 4 bins, that's 3 degrees of freedom. The table may have a 2.5%, but if I ask you for 5%, a chi-squared test, for reasons we'll discuss after the midterm, a chi-squared test and a KS test, there's only a one-tailed version of it. There's no two-tailed versions of that. So you don't have to worry about dividing. There can only be one difference, one distance. You can be a chi-squared and KS test, or how different from the null are you? And you can only be positively different. You can't be negatively different than the null. That's why we don't worry about this two-tailed thing. So if I ask you for a 5% alpha, you go to the 5% column, but make sure it's one less than the number of bins. And KS test. So you guys got a chance to play with this on your homework, sort your numbers, and then put the expected range for a uniform around them. That's what is up top here. So if you have 10 numbers, then this will be 0.1, 0.2, 0.3, all the way up to 1.0. If you have 4 numbers, this will be 0.25, 0.5, 0.75, and 1. So, and then this is just a shifted version of it down here. So these give you these intervals which chop up 0 to 1 based on the number of numbers you have. Then you can calculate the distance from each boundary of those, and that's what shows up down here. The maximum distance is what you look up in the table. The key thing here is the degrees of freedom are the number of data, not the number of data minus 1. So if I have 20 data points, you go to row 20. If I have 10 data points, you go to row 10. Likewise, if I give you an alpha of 0.05, you go to the 0.05 column. You don't go to 0.025. Questions about that? And so then this is just showing autocorrelation here. I'm not going to ask you about this on the midterm. But then the last one, just to have it up here, is the runs test, our most recent test. So similar scheme here. I give you 30 data points. I'm not going to ask you to take the mean of 30 data points. If you need the mean of 30 data points, I will give you the mean. So I will end up calculating this for you on the midterm if you need it. It'll be somewhere, it'll be hidden somewhere in there. But if you find yourself adding more than like 5 numbers together, then you're either doing something that maybe I didn't ask for, or you missed something that I gave you. And so calculate the mean, convert each number into a coin flip that is weighted by whether it is above or below that mean. So we've got a bunch of tails and some heads, 0 if you're below the mean, 1 if you're above the mean. Once you have that, then you can see how many runs you have. And those are, these are broken up this way. So whenever you switch from one sign to one symbol to the next, that's the end of one run and the start of another. Runs can be one symbol long, that's fine. And then you count up the number of runs. So there's 19 runs in this 30 symbol sequence. So from there, if I know the number of runs, I know the number of heads, I know the number of tails, then I can calculate and know these formulas. So write these ones down on your cheat sheets. I can calculate for a independent coin that is biased that way. So it's an unfair coin that is nevertheless independent. Then this is the distribution of runs. It's a normal distribution with this mean and this variance. So I know the actual number of runs. I know a normal distribution describing the runs I would get if it were an independent coin. And so from there, I calculate a z-score where I plug that in, I get a number here. Make sure that you take the square root of the variance when you're calculating that z-score. That's another easy thing to miss. And you didn't look in your table here. This is I'm going to give you a one-tailed table, just as is convention. But for this here, take this to be the absolute value. And so because you're taking the absolute value, it is possible for this thing to be negative. That's the reason why we have to worry about this one-tailed, two-tailed thing. So if I ask you for a 5% type 1 error, then you got to look in your table for 2.5%. And because that's only one tail. The other tail adds to that. That's where you get your 5%. And so that gives me a critical value of 1.96. That's sort of a famous number. I probably will ask you for a 5% error rate. So that's probably going to be the number. And then you can compare the z-score to that. If it's greater than that, then we've detected a lack of independence. If it's less than that, then it is consistent with our model of independence. So a model, a what if question. What if we had an independent coin? What would the distribution be? And there's our model of what the distribution would be right down here. Again, write that down on your cheat sheet, these formulas. And remember to take the square root. And then inverse stuff. So I've already beat you over the head with a lot of this. So I'm not going to go too much more than this. But just be careful with the piecewise stuff. Make sure to break your things in parts into boundaries. Solve the inverse problem for each piece, but make sure you're careful about your ranges. Take your random number, plug it in to get your variate. And I could ask you to generate variates. And again, typically I might do is they say generate 5 variates and give me the 5th one, and that'll be the answer to the question. And so I'll probably, if I ask you to do that, and you'll see me do this on previous midterms, I'll give you a string, a bank of random numbers, kind of like having, in the homeworks, I give you a bank of inter-arrival times and a bank of service times. I'll give you a bank of random numbers that I've generated, and they'll just be like up at the top. And then I'll say, starting from the left-hand side of the random number bank, generate 5 random variates and give me the 5th one. And then that will tell you that, well, for my random variate generator, I could just go to the 5th number and then plug that 5th number in. And then whatever value I get out, that's the answer. I don't need to actually generate all 5. That me asking you to do that is me testing you to see if you know that, oh, I'm going to go, if I did that, I would go over 5. Like the 5th random number would end up being what generates the 5th random variate. Okay. And yeah, there's a graphical depiction of all of that. Just if you don't need to know a table like this, but just providing that if you need to see examples of inverse CDFs, here's a table with inverse CDFs for a bunch of common PDFs. I think that's pretty much all I've got for you. So, I guess I let this up here. Know which one of these is a PDF, a CDF, and an inverse CDF. Know which one of these is likewise that, that sort of little trick that we did earlier. And I think that's all of the stuff I've got prepped. So that's everything we've learned this semester in less than a lecture. Any questions? Yep. You mean this? No, I was just highlighting the quantile functions that this column, if you're just looking for other examples of how to get from PDF to CDF to quantile function, then those are quantile functions, but you don't need to memorize these. Anything else? I don't have a clicker question. It's just a review session. I didn't want to penalize anybody for not coming, but hopefully you get the benefit of the review. If you have anything else, feel free to email me. Once the exam is out and released, I can't answer a lot of questions anymore. I can answer like procedural questions, but not content questions anymore. So Monday, I'll be off limits for content questions. Uh-huh.
Last year, I received one of those messages that I was working on.
Okay. I get that. Well, I mean, and that can go into your drops, but that's just, it's one of those, if you don't know it, just leave it blank. That would be because if you put something that's counter, then as far as I know, you're like in your dorm just waiting for the like, yeah. Uh-huh.